There have been many new features added to C# to help you write cleaner code. You might not know about them, or you might have forgotten them. Let's recap. Let's start with file scope namespace. In the past, a namespace used to be wrapped around curly braces. That meant that the class was indented, leading to less horizontal space on the screen. But with file scope namespace, we could add a semicolon, remove the curly braces. The namespace now acts throughout the file, and the class is at the same indent level, leading to more horizontal space. Find yourself using the same namespaces over and over again? Well, the global using directive will help you. We've got a couple of namespaces. We've got a models namespace and an exceptions namespace. In the past, if we wanted to import each one, we'd have to do it individually by using the using directive. But with the global using directive, we can globally import them into the project. So if we copy these and we're going to paste them into a separate file called global using, we're going to add global to the beginning of each one. And by adding that, that means that these namespaces are available throughout our project. As a result of that, we can remove the using statements here, and that means that those namespaces will be imported throughout all our files. Looking at target type new expressions, if we wanted to initialize this class, we'd have to specify the type that we're initializing, even if we know the type already. But with target type new expressions, we can just remove the type and it knows to create a new instance of the my class. And this also works with parameters as well. So if we specify some parameters in the constructor, we'll pass that in when we're initializing it and it will still compile properly. Now obviously this is not going to work if we're using file because it doesn't know what type of class it's initializing. With using declarations, if we were initializing a class that was disposable like the stream reader, we could wrap it around a using statement and it'd be disposed of at the end of the curly brace. But we can make some changes to this, so we can remove the braces around the using declaration, we can add a semicolon, remove the curly braces, and that means that we have one less indent level. It would now be disposed of at the end of the method. Looking at init-only setters, in the past if we wanted to add values to these read-only properties, then we'd have to add them in as parameters in the constructor and then set them within it. But with the init-only setter, we can add init to the property, so we do it for both of them. We can now remove the constructor. Now when we initialize the class, we can add them as part of the initialization. So we'll add A as 1 and B as hello. Now if we try to change one of these, so if we try to change B to something else, it throws a compile exception. Interpolated strings was added some time ago. This allowed you to add a variable within a string without coming out of the string. This was done by adding the $sign before the string. This was further extended with constant interpolated strings, so we could add constant string, and we could also do it for the language text now, and it's still compiled properly. More cleaner code features to come. When a new major version of .NET is released, it also ships a new version of C#. But did you know that you can use the newest C# version in older versions of .NET? To do that, we need to make a change to our project. We need to make a change to the CS_proj file. In Visual Studio, you can right-click on the project and go to Edit Project File. Now this project is using .NET 6, but to use C#12, which was part of .NET 8, we can specify the lang version and we can just declare that as 12.0. This is now using C#12, despite the fact that it's a .NET 6 project. To make this work, you'll need the .NET version installed on your machine that corresponds to the C# version that you're using. If we wanted to use C#12, we'd have to download .NET 8. And we know that because we're on the .NET SDK page, and if we scroll down and go to language support, we can see that C# version 12 is supported in .NET 8. Let's get back to the C# cleaner code features, and we're going to have a look at recursive patterns. Switch statements used to use a lot of lines of code. In this example, we've got a rating integer and a rating description. If the rating is 1 or 2, the rating description is set to bad. If it's 3 or 4, the rating description is set to OK. And if it's 5, the rating description is set to great. By default, the rating description is set to unknown. But this can be reduced significantly using a switch expression. So to do that, we call rating, then we call the switch keyword and wrap it around curly braces. If it's 1, we set it to bad. We do the same for 2 as well. For 3, we set to OK. And we'll do the same for 4 as well. Set to 5, we set to great. And by default, which we use the underscore for, we set to unknown. So this significantly reduces the lines of code that we can use using switch. But that switch expression can be simplified even more by looking at logical and relational patterns. This switch statement is adding a lot of duplicate entries, but with logical patterns we can simplify it even more by using the or and statements. So to do that we set 1 or 2 as bad, that means we can remove 2, and we can set 3 or 4 as OK, that means we can remove this line. And we can also make changes to it using relational patterns. So we can say if it's greater or equal to 3 and it's less than and equal to 4, it's OK. So there are a couple of ways you can use switch expressions using relational and logical patterns. List patterns allows us to pattern match an array. We have a myNumbers integer array with the values of 1, 3 and 5. To pattern match we call the myNumbers, we call is, and we put it in an array of 1, 3 and 5. Running this sets the is pattern to true. If we were to change this, so if we set the end 1 to 6, it's going to return false. Now we can add some other things on here, so we can add an underscore on there, put the end 1 as 5. That means that this middle number can be any number. So if we changed it to 544, the is pattern is set to true. We can also add 2 dots there. That means that this middle part can be any length, so we can add some extra numbers on there. And this is still set to true. That means we don't have to write complex linked statements to do pattern matching. Collection expressions brings the spread operator to C#. We have 3 different collection types here. We've got an int, a span and a list collection. We've got the A, B and C. We're going to join them together in this list. So to do that we do .a, .b and .c. So now join will have all the values in A, in B and in C. We can also add some additional ones. So we can add a couple of extra additional numbers. We could also add one at the beginning. And when we run this, it adds all the numbers from A, B and C as well as our additional ones. Let's have a look at primary constructors. By default, a constructor would be parameterless if it wasn't declared. If we wanted to add one with parameters, we'd have to declare the constructor, pass in the parameters and set it within it. But with primary constructors, we can now add the parameters to the class. So we can remove it and put that up there. And that essentially means we don't need any of this code. These parameters here are now available throughout the class. Now we can demonstrate this by writing a method. So we're going to declare a method getStartTime in hours. And we're going to return the start time and the total number of hours. Now when we declare this, we're now going to write to our console application the start time in hours. We're passing in the start time of 9 o'clock. And that is returning 9. Primary constructors also works with dependency injection. Watch this video next to find out how. And if there were any particular C# features that you like, or the features that you felt should have made the video, leave a YouTube comment about them. I look forward to reading them.